Okay, so I'm going to first give the disclaimer that I just moved and I didn't. I only got to put about 2 days directly into the presentations tonight when I wanted to put in 3. So it's not quite as ambitious as I wanted. But on the other hand, when I looked at the syllabus that I outlined for tonight and compared it to a CS 500 level course, we're actually trying to cover about 5 lectures. We're covering probably 4 1-hour lectures worth of stuff out of about the first 7 lectures of a semester. So it's probably okay that I didn't get to cram it quite as full, and I abbreviated it a bit. So that's my first disclaimer. My second disclaimer, hey, this is not trading advice. I am not a CFA, I'm not a CPA, and in fact, technically, I just left Google, so I'm no longer a software engineer. But yes, I'm now free. So I will be doing this full time. So let's see. Other interesting things. So I have done the machine learning both at Amazon and at Google, and I've been doing it as a hobbyist for probably the last 20 years. So I probably do have about 2 solid years of various forms of machine learning, mostly that I apply to trading. I got a bit more formal in preparation for this series of talks. So Suri did ask me to do a whole series of talks, and I thought it would be good if we went back to basics and got some of the fundamentals. Yeah.
Before you start, could you talk about the software applications? Are you using MATLAB?
So
what software are you using?
I'm using Java with a library called Smile.
Okay.
So Smile is basically a Java equivalent of Python's scilern, only it tends to be about 100 times faster. So 100, a little more, depending on the particular application. So the thing to remember about Python is it's actually very, very slow. Right? So just out of the box, it takes about 120 times as long to execute as Java. So when you do things in Java, you get some better execution. I could have gone to C++, but the cost balance trade-off between performance versus what I could get out of it versus the developer productivity. You know, I've got, this will be my this is midway through my 22nd year of Java programming, so I'm fairly familiar with it, and I can do it just kind of like.
Yeah, Ernest Chit has mentioned in his latest book, has mentioned that he does his research for not quantiparian or whatever, but when he's finally done, he goes to C#.
Okay, yeah, C# is great, yeah. C# is very Java-like, and it's compiled and has all that good stuff. There's definitely nothing magical about the libraries that I use. They just give me a lot of algorithms that I don't have to re-implement. But that tends to be what I've been using lately. Any other questions if we have some other folks who are familiar with some of the tools?
So do you only basically did it because in Java because it's easier for you, but like sklearn from Python and it has already much algorithms there.
So I have a similar set of algorithms, but in 1 hour I can run the amount of machine learning that I would run in 100 hours in Scilern. Plus, it's easier to do threading in Java. So I bought a many cored machine so I can actually then multitask it. I haven't quite gotten to the point where I've actually implemented the multi-threading and decided exactly what I want to do. I've conceptualized it and I'm going to go implementing it. So pretty soon I'll be running it about 500 times or better. I'll have to see what the diminishing return is on number of cores. But you got a 16-core machine, overclocked, water cooled, all that stuff. Presumably it'll be fast. Now, the yet faster way would be to go with something like, so I could go with TensorFlow, but the only way that that's really going to be faster is if you use a native implementation like Google's TensorFlow in the cloud. So when they run on their tensor processing units, they actually offload all the heavy lifting onto GPUs. So if I use that optimized implementation, then Scilern and TensorFlow would be faster. Alternatively, I would have to write all of the CUDA code myself. There are some libraries that I am looking at using. So there are some I'm trying to remember what they all were. I made a list of them, basically on that to-do list of things for me to check out. Because potentially, so I did also get a mini core graphics card for the day when I decide to go ahead and offload to the GPU. So I do have like the 1600 core graphics card, and yeah, okay, they're running at a fifth the speed of my CPU cores, but I have so many of them that I should be able to get probably a 50-to-1 ratio there. So I might be able to get about 5,000 times if I use the CUDA libraries, JCUDA for the interface, and make all that stuff, offload everything to the GPUs that I can, stuff like that. So I do have some experience with some of that stuff in 3D graphics programming. I haven't done the CUDA stuff in great detail, much beyond like Hello World and some things like that. So there's a lot of opportunity for optimization. This talk is actually not going to be about all of the tools and implementations like that. This is actually prerequisite for some number of series, which is basically up to you guys. So Suri asked me to do some introductory talks, and basically these 3 talks were about the minimum that I could figure as being able for people to have a common ground and be able to talk reasonably intelligently about machine learning. So after that, it'll be, what do you guys want to talk about? So one option we have is to go down, like the CS 500 level and go into some books that are based on that. I've got a book with a curriculum. I stole a few slides. I didn't steal them, they're given with permission. But I did use a few slides out of the curriculum that I selected. So we could actually do that in great detail, or we could just do selected bits. It's really up to you guys, and we'll probably have some more time later to talk about exactly where you want to go with it. Okay? So, the grueling stuff, the unfun stuff. So, I don't know everybody's math background, so I'm going to assume not everyone has, or still remembers, as it was my case, the details of linear algebra. Much of machine learning actually depends on linear algebra, right? So basic Wikipedia definition, right, it's a branch of mathematics concerning itself with vector spaces. So in particular, we're able to translate things to vector spaces. So it concerns itself with linear mappings between such spaces. So this becomes important because things that we see in 2 or 3 dimensions as like funky lines or funky curves and stuff actually become flat in a higher order number of spaces. Right? So in order to do that, we want linear mappings between these various spaces, and then we want to get to a point where everything's linear and then various mathematical properties apply. So most of machine learning is based on matrix multiplication, which is why linear algebra becomes important. So it also exposes these things. So linear algebra can be used for solutions of linear systems. So guess what? That works well with trading. Right? So I have constraints. Right? So only so much volume can trade. I have constraints about when earnings events are going to happen, when our options expiration events are going to happen, all those kinds of things. Those can be represented mathematically. And then we do have some Fourier series expansion. This mostly comes in, ideas related to Fourier series expansion really come in with neural networks. So, yes?
Is there an assumption, as you're talking about your experiences, that the systems are mostly intraday or end of day or
So my systems are intraday. So I tend to be, this has to do with my trading thesis. So my trading thesis is that the number of observations is critically important, and we'll talk about quantifying that. So previous to this series of discussions, I hadn't actually quantified it. I was roughly where everybody else is. Well, oh, law of large numbers. Well, it turns out there's some other things at play, more detailed than just law of large numbers. And it turns out that concerning ourselves with a specific confidence interval is actually critically important to how many observations we need. And then, of course, we get into the independence of those observations, the correlation of those observations to each other. So who here thinks that today's price of the S&P 500 is completely independent of yesterday's price? Good. Nobody. Okay, so those are not two independent observations. So the law of large numbers does not apply to those two observations. Right? So we are already starting with an area where law of large numbers is insufficient to describe our data. Right? So we have to look to other things. So, but nonetheless, intraday still gives me way more observations than daily.
And this is why you mentioned speed was important.
Yes. Yes. Speed becomes critically important when I actually want to throw, 200,000 observations and I want to test, say, 200 trillion or 200 quadrillion hypotheses against those 200,000 observations. Yes.
So, sort of off topic. So you do intraday, and I have not heard this brought up yet. This seminar. How do you deal with non-display fees?
With what?
Non-display fees.
With non-display
Fees.
feeds. Oh.
Are you familiar with those?
No.
So those have come out in the last 2 years where they actually start charging you for analyzing data that you do not display on the screen.
Oh, my broker doesn't. So.
So apparently they are actually starting to push this with brokers, a number of them. All the major exchanges are doing this. The New York Stock Exchange is infamous for this because they charge you $6,000 a month for doing this. A number of brokers are pushing this through. It's just something to be aware of. If you do analysis on real-time data that's anything more recent than 15 minutes, I know some brokers are sending out letters to their customers that they are going to start forwarding these costs onto their actual customers or clients.
What is this again?
They're called non-display fees.
And what is that about?
Basically, if you do any sort of data analysis that's not displayed to a screen, they will charge you money extra for that.
Which broker charges?
It's through the exchanges.
The exchange is charging.
The exchange is charging the brokers. It's questionable whether the broker actually passes it on.
Right, but I do it all the time, but I'm just trying to say.
So the brokers, apparently they're putting more pressure on the brokers these days to forward these fees onto the clients.
Right.
I know for a fact that Lightspeed is forwarding these fees onto its clients. I've talked to a number of independent data fee providers, like Quant House. They are starting to forward on these fees to their clients. I know IQ Feed is not forwarding these fees yet. It's something to be aware of in this space. It's caused a lot of turmoil. Charging $6,000 a month to do this is definitely doesn't seem fair.
Seems unlikely they'll charge that per individual investor.
Oh, well, that's what they're doing. That's why it's such a big. Well, so
Somehow my Interactive Brokers is giving me my data for $30
Yeah,
a
so-
month, and it's everything for the entire market.
I know there's been a number of complaints to the SEC about this.